So the third and last way that we're going to look at, there are more than 3 ways, but we're only going to look at 3, is solving by substitution. Okay, so you're going to get one variable by itself in one of the equations. Now sometimes that's going to be done for you, and the first example we look at will have a variable by itself already. All right. In other cases, we're going to have to do that. Next, you're going to substitute that expression. That's on the other side of the variable it got by itself. So if you got y equals something, you're going to take that something and you're going to plug it into the other equation. So what you'll have done, after step 2, what you'll have done is you'll have created one equation with one variable. All right, that's the whole point, is we're trying to take it from 2 equations, 2 variables, down to 1 equation, 1 variable. So then from there you just have to solve that. And then you'll get one of the variables. And then from this point, it's just like elimination. Then you take that, plug it back in, see what you get, express your solution as a point. Okay, and that's the last step. Just make sure you plug it into one of the original equations. Don't plug it into the equation that you maybe manipulated, because if in case you do this wrong and you plug your what's now wrong answer into a wrong equation, it might give you a false sense of confidence that you actually have the right answer, when in fact, if you would have plugged it into an original equation, you probably would have figured out that you made a mistake in here somewhere. So that's why I like to use original equations, not one of the equations that you changed around already. Problem number 1. Okay, here's the first one. Y equals 2x plus 5. 2x plus 3y equals negative 17. This problem is already set up for us, right? There is a variable by itself already. Where? Well, that's the way we can do the problem. Otherwise, we can't do the problem. Get it? No? Nothing? I said y. You said y, and I said so we could do the problem. Thank you. Thank you. Yes, thank you. I'm here all day. I'm here all day. Thank you. Yeah, that was a joke. No, that's a bad math teacher joke for sure. It's worse than a dad joke. Okay, so here's what we're going to do. We're going to take 2x plus 5. Since we know that that also equals y, and we're going to substitute it in for y in the other equation. Okay? And then I will have an equation that has nothing but x's in it. So here's what I have. I've got 2x plus 3 times, correct, I need the parentheses, 2x plus 5 equals negative 17. So that's, I've substituted into the second equation. Okay? So now I just need to go ahead and solve that, and I'll know what x is, then go through your process to find y. Okay, so go ahead and finish that problem up. So, I would have 2x plus 6x plus 15 equals negative 17. This is 8x plus 15 equals negative 17. Subtract 15. So 8x equals negative 32. What does x equal? Negative 4. Okay? Now, I can plug it into either equation. Here's the thing. I haven't used the first equation, and y is already by itself, so I'm going to use that one. So I'm going to say y equals 2 times negative 4 plus 5. So y equals negative 8 plus 5, so y equals negative 3. My solution needs to be expressed as a point. How many got that? Raise your hand. Very good. Okay, so that's the general gist of substitution. The next 2 examples, listen please. The next 2 examples will eventually get us down to a situation like this. But they don't start off like that. But understand that our goal here was to get one of the variables by itself. It was already set up like that. In the next 2 problems, it's not going to be set up like that, and we're going to have to get it like that. Okay? So here's the next one. Okay? X minus 3y equals 4, 3x plus 4y equals 38. Now, in some cases, in this problem, there is not a variable by itself already. However, in some cases, it makes more sense to get a specific variable by itself in a specific equation. That is not to say you have to. I'm trying to help you find an easier way to do this. And in this case, there's one variable that's kind of by itself, and in one quick little move, we can get it by itself. Which one is that? In which variable? In which equation? Sorry. In the top equation. So this x right here is kind of by itself. So to save yourself the trouble and save yourself the steps, right, if you just add 3y to both sides or move 3y to the other side, now I can get the x by itself pretty easily. Okay, so in one little move, I can get the x by itself and put it into a situation where I can do substitution. And so here's what's also important on your quiz, on your test. I will ask you, because some of you right away were like, well, I just multiply this by -3 and then I can do elimination. I'm going to make you show that you know how to do substitution. I'm going to make you show that you can solve using elimination and graphing. You have to know all the ways. All right. Eventually, I'll just leave it up to you to do whichever way you want. Okay. But you're going to have to demonstrate that you know all three ways. So go ahead and finish this problem if you haven't already, and then we'll see what you get. Now, here's what I would do. Now, something that will happen occasionally is you'll forget which equation you started with, and you'll plug it into the same equation. So if you did that, if you took this and you plugged it into the first equation, which this is the first equation still, really, everything's going to cancel out, and you're going to think it's all infinite number of solutions. So be careful, don't do that. Plug it into the other equation, so it goes in there. Okay, so I've got 3 times 3y plus 4 plus 4y equals 38. So that's 9y plus 12 plus 4y equals 38. That is 23y equals... Nope. Why did I get a 14? Start over. Back it up. Because the plus looks like a 4. 14. All right. So that's plus here. Try again. 13y equals 26. That's better. Subtract 12. Y equals 2. Okay, we good?
Yes, sir.
All right. Now, choose an original equation. And again, I'm going to choose the first one just because. You could choose the second one and it would be fine. That would be 3 times 2 equals 4. So x equals 10. So my final answer is 10, 2. How many had that? Very good. All right, one more. One more. Okay. 4x minus 2 equals 2. Negative 7x plus 9y equals 13. Bless you. Now, we have to do substitution. Here's my issue, right? In this problem, not only is there not a variable already by itself, but there's not one that's sort of by itself, like the last problem. So you have some options. You could just make a choice and say, I'm going to get the x by itself in the first equation, or I'm going to get the y by itself in the second equation. But the one thing that I would encourage you to do is try to figure out a way to minimize the number of fractions that you have to deal with. And in this particular problem, choosing to get one variable by itself in one of the equations will help facilitate that. Okay? Any thoughts about which variable you want to get by itself?
Y.
Jasmine, what do you want?
Y.
Y in which equation? The first one or the second one?
Add 2 1.
Get y by itself in the first equation. Why do you feel like that's be a good thing to do?
Because then you'll get a fraction.
How do you know that?
Because when you move 4x to the right side,
Okay?
and then you have to divide by -2,
Yep.
you get 2 instead of 1/2 if you were to solve for double.
Very good. So if you would have got 4x by itself and moved the 2, now you're dividing 2 by 4 and you're going to get a bunch of fractions that way. None of these are multiples of each other, so you're going to get a bunch of fractions if you use this one. Here you can be strategic. Again, it'll work in any of them. Okay, you can choose to get whichever one by itself you want. But if you analyze it a little bit and try to figure out a way to minimize your risk of getting a fraction, if you start with getting this by itself and then eventually getting that y by itself, you will not have fractions for that rearrangement. So notice here what would happen. I get negative 2y equals negative 4x plus 2. Then we're going to divide by negative 2. And you have to divide everything by negative 2. And like Jess said, no fractions. Okay. Let me say that again. You could get any of the variables by itself, even if you get fractions, and it will still give you the correct answer. It will just create a little more heartache for you, because I know how you feel about fractions and operations with fractions. If you don't have any anxiety about fractions, then you can just get whatever variable by itself when you want. If you want to see if your answer is correct, all you've got to do is plug it back into both equations, and you don't necessarily have to write that out. But a quick check, plug in your x and y, see if this equals that, and then do it down here. And if they work out in both, then you probably did it right. Okay. All right. So now again, this is the first equation that I manipulated. So I'm going to plug it in to the second equation. 7x plus 9 times 2x minus 1 equals 13. So this is negative 7x plus 18x minus 9 equals 13. That is 11x equals 22. X equals 2. Okay. Then I'm going to plug into the first equation. 4 times 2. Minus 2y equals 2. 8 minus 2y equals 2. Negative 2y equals negative 6. Y equals 3. My final solution, 2, 3. How many have that? Very good.